Let's review some preliminary ideas regarding quadratic relations. In this video, what I'd like to go through is identifying the three key forms of a quadratic relation, so standard form, vertex form, and factored form. And what I'd also like to be able to do is to identify which key features are being shown regarding the parabola in any given form. All right, finally, what we want to also be able to do is use our algebra skills to convert a quadratic written in factored form to standard form, or from vertex form to standard form. Let's have a look. So first thing we're going to look at is the main key features of a quadratic relation. So when we graph a quadratic relation, what we get, the shape that we get is known as a parabola, and parabolas have a number of key features. All right, now this parabola is written in standard form, all right, and you can always identify the equation of a parabola or a quadratic relation by looking at the exponent because it is a degree 2 equation. Okay, a degree 2 equation. All right, so we have this quadratic y equals x squared minus 2x minus 8. Let's graph it and have a look at its key features directly from the graph. Okay, so when we produce that graph, we can see that the parabola opens up. All right, so the direction of opening is up. The y-intercept looks like it's right over here where the parabola crosses the y-axis. That's negative 8. And the x-intercepts looks like it has two of them, an x-intercept at negative 2 and another x-intercept at positive 4. The vertex of a parabola is where the parabola changes from either decreasing to increasing or vice versa. So we can see here that the vertex, which happens to be the lowest point of the parabola, which means it's a minimum value, the coordinates of this vertex looks like it's the point 1 and negative 9. Now the axis of symmetry is going to be a vertical line that cuts the parabola into two equal halves. And that axis of symmetry, that vertical line, is always going to go through the vertex. And then an interesting thing about the axis of symmetry is that it's right in the middle between the two zeros. So you can see that this x-intercept at negative 2 and this x-intercept at 4, the axis of symmetry is right in the middle between those 2 points. This axis of symmetry always has an equation of x equals, and it's always going to be the x coordinate of the vertex. So in this case, x equals 1. So the equation of the axis of symmetry is x equals 1. And that will always match the x coordinate of the vertex. All right, in this case, we have a minimum value because the parabola opens up, and the minimum value in this case happens to be negative 9. All right, so this will always be the maximum or the minimum, and this is the axis of symmetry. All right, so the vertex is really, really important. Now we know that this parabola opens up because we can see that the coefficient of x squared, there's a 1 there, it happens to be positive. Let's take a look at a parabola that opens down. So y equals negative x squared minus 4x plus 5. If we graph this one, also in standard form, notice the negative in front of x squared. This parabola is going to open down. The y-intercept, we can take a look at the graph and see that the y-intercept is positive 5. And it has two x-intercepts, one at negative 5 and one at positive 1. The vertex, we can see it right up here, has a coordinate negative 2 and positive 9. The axis of symmetry, that's once more the vertical line that cuts the parabola in half. That axis of symmetry will always go through the vertex. and its equation is always going to be x equals whatever the x coordinate of the vertex is. So in this case, x equals -2. And then finally, the maximum or the minimum value, because this parabola has a vertex at -2, 9, and because it opens downwards, okay, we know that that vertex at -2, 9 is a maximum value, and the maximum value is equal to 9. All right, so when we talk about key features of parabola, these are the kinds of things that we're talking about. The direction of opening, the y-intercept, the x-intercepts, or possibly the x-intercept, because parabolas can have only one. The vertex of the parabola, again, and that's where the parabola changes from decreasing to increasing, or in this situation, from increasing to decreasing. The axis of symmetry is really important, and also the maximum or minimum value. Those last two are pretty closely tied to the coordinates of the vertex. Okay, so that's a preliminary little discussion on key features of a parabola. Let's have a look at some different forms of a quadratic. So quadratic relations can be written in 3 different forms. We have standard form, y equals ax squared plus bx plus c. We have factored form, y equals a multiplied by x minus r multiplied by x minus s. And we have vertex form, y equals a, x minus h squared plus k. In either of those instances, the a value has to be non-zero. Otherwise, it wouldn't be a quadratic relation anymore. Now, each form of the quadratic relation gives us different pieces of information, and here they are. Starting with standard form, which is the one we just looked at, when a parabola is written in standard form, we know that the value of a tells us whether the parabola opens up or down. The value of a is also going to give us the shape of the parabola, if it happens to be very narrow or if it happens to be a lot wider. If a is positive, the parabola opens up, and if a is negative, the parabola opens down. Now, the interesting thing about standard form is the c value is going to give you the value of the y-intercept. Now, factored form is another interesting form. Factored form is written as y equals some coefficient a multiplied by 2 binomial factors, x minus r and x minus s. The value of a gives us the same information as it does in standard form, namely the direction of opening and the shape of the parabola. But the value of r and the value of s in factored form gives us information about the x-intercepts, or the zeros. And then finally, vertex form is written as y equals x minus h squared, so a binomial squared, plus k. The value of a works the same way as it does for the other two. But vertex form gives us the value of the vertex. So the value of h is going to be the x-coordinate of the vertex. The value of k is going to be the y-coordinate of the vertex. So each of these forms are very useful for solving associated problems, depending on what kind of information we are looking for in the problem. Okay, some quick examples. Example 1, we have y equals 2x squared plus x minus 3. And we want to, from this quadratic, identify the direction of the opening, whether the vertex is a maximum or a minimum, and the y-intercept. So this parabola is written in standard form. Y equals ax squared plus bx plus c. So the a coefficient happens to be 2, the b coefficient is positive 1, and the c coefficient is negative 3. Because it's written in standard form, we know the direction of the opening based on the value of a, and we know it's going to open up. Again, and that's because the a value of 2 happens to be positive. Because the quadratic opens up, that means the vertex is going to be a minimum value. And then finally, the y-intercept of this equation is just going to be the c value, so it's going to be -3. That's about the most amount of information we can get just by looking at the equation written in standard form. If we graph it, however, we can see all those key features. All right, so there's our y-intercept of -3. And we're not able to determine these zeros, not unless we manipulate this equation a little bit or determine them from a graph. Now, a quadratic written in factored form. So in this one, we have y is equal to -1 multiplied by x minus 3 multiplied by x minus 7. So this is factored form. All right, that's what the general form looks like. In this case, in our example, our a value is -1. So what we can do is we can take something that's written in factored form and use FOIL. That's the technique of first, outside, inside, last when multiplying two binomials. So we could expand this and convert it into standard form by expanding. So let's do that. I'm going to just leave that -1 out for a minute. And I'm going to expand, so x times x first. X times -7 would be -7x. So x squared minus 7x. Then the inside terms, -3 and x is -3x. And then finally, -3 times -7, positive 21. Okay, we'll collect our like terms. So -7x minus 3x is -10x. And then finally, I'll distribute that -1. So I'll have y equals -x squared plus 10x minus 21. So now that I know what this quadratic is, what this quadratic's equation is in standard form, I can determine the y-intercept because it is the c value. So that's -21. And the x-intercepts can be found just by looking at the equation in factored form. So because our equation in factored form is y equals -x multiplied by x minus 3 multiplied by x minus 7, our zeros, or our x-intercepts, are going to be +3 and +7. All right, you'll have to remember that whatever the sign is in the equation, the x-intercepts are going to be the opposite sign of that. So in this case, it's x minus 3 and x minus 7 in the equation. Our x-intercepts are going to be +3 and +7. And now for D, what we can, once we have the x-intercepts, we can figure out the equation of the axis of symmetry, because we know that the axis of symmetry is always halfway between the two x-intercepts. So to figure out that axis of symmetry, we're going to take the first x-intercept 3, add it to the second x-intercept 7, and divide by 2. So 7 plus 3, 10 divided by 2, we end up getting 5. So the axis of symmetry is x is equal to 5. All right, now let's graph this. So I'll get the computer to graph it. And when I do that, this is what we end up getting. And so take a look at all the different key features. Here's our x-intercept of +3, and here's our x-intercept of +7. Now the axis of symmetry, like we just calculated, is going to be halfway between those two zeros, and we work that out to be positive 5. And in fact, from our graph, that looks pretty good. Now we can determine our vertex once we have the axis of symmetry. So if we know that our axis of symmetry is x is equal to 5, and if we know our equation, I'm going to write it in function notation, f of x is equal to negative 1 times x minus 3 times x minus 7, I can figure out the y coordinate of the vertex by substituting 5 into the equation for x. So substitute the value of the axis of symmetry in for x, and then work this out. So 5 minus 3 is 2. 5 minus 7 is negative 2. Negative 1 times positive 2 times negative 2 is going to give us positive 4. So that tells us, therefore, that the vertex has to have coordinate x equals 5, y equals 4. Because this parabola opens down, we know that this vertex has a maximum value of 4. All right, and here it is. In the graph, we can see it right here. So there's the vertex of x equals 5, y equals 4. Okay, one final example. Example 3. This time we're going to graph the quadratic relation y equals negative 2 times x plus 1 squared minus 6. So this quadratic is written in vertex form, so we can see it here. X is equal to, y is equal to a times x minus h squared plus k. So our a value is negative 2. Our h value is negative 1. All right, I know it's plus 1 in the equation, but when we have an h value of negative 1, the negative 1 and this negative in the equation gives us a positive 1, and our k value is negative 6. So once more, we can convert this into standard form by expanding. So I'll do that now. So I'm going to rewrite x plus 1 squared as x plus 1 times x plus 1. And then we have minus 6. We'll do x times x, and then x times 1, and then the inside terms and the outside terms. So we'll multiply those two binomials. We end up getting x squared plus 1x plus 1x plus 1, and then minus 6. Collect like terms. Okay, when we distribute and collect like terms, we will end up getting negative 2x squared minus 4x. Negative 2, and then negative 2 minus 6 will give us negative 8. All right, so I'm distributing that negative 2 inside that trinomial that's within the square brackets, and then collecting like terms. So from vertex form, we converted this quadratic into standard form. And taking a look at standard form, we can see that the c value is negative 8. So our y-intercept is equal to negative 8. Now we're going to determine the equation of the axis of symmetry, but this time we're going to do it from the graph. But if we have this quadratic in vertex form, we can see that the vertex will also give us the axis of symmetry. So let's graph this. And this is what we have. And I'll draw that axis of symmetry right on the graph. And that's going to go right through the vertex. And so that axis of symmetry is going to be x is equal to -1. Now we can see that the vertex from the graph here is the point -1 and -6. And notice our equation was written in vertex form, which was -2 times x plus 1 squared minus 6. So what you need to see here is that vertex form will give us the coordinates of the vertex. This is the h value and this is the k value. So our vertex is going to be -1. So that's the opposite sign as it's presented in the equation. And then the same sign as the k value. So -1, -6. And there's the vertex at -1, -6. And so we could have also gotten the axis of symmetry just by looking at this equation right here without the need to graph it, because vertex form gives us the vertex. And so if we have the vertex, we also have the axis of symmetry. So this axis of symmetry would be x is equal to -1. All right, so from the equation, from the vertex form equation, we know that the vertex's coordinates are -1 and -6. And because the parabola opens down, the vertex is a maximum point. And the maximum value is -6. Okay, that's it for now.